Right. Next, second one, magnetic field due to circular coil or a circular loop. So previously we discussed magnetic field due to straight wire carrying current. So in which direction the current is flowing and in which direction the magnetic field is formed. So in case of straight wire, the magnetic field is formed as a concentric circles around the wire, around the wire. Then let us understand what about in case of circular coil or a circular loop. Circular coil or circular loop. For example, circular coil or loop. Circular coil or a loop. So, in case of circular coil, in which direction the magnetic field is formed? In which direction the magnetic field is formed? Right? So here we have to place a magnetic compass. In straight line movement, then in case of circular coil, ఇలా ఉందనుకుందాం. Okay, straight current carrying conductor ki we understood. Then if the current is passing like circular loop or circular current carrying conductor, in this case, in which direction the magnetic field is formed? Magnetic field is due to circular coil or a loop. Right? So we know that current passing through a straight conducting wire, a magnetic field is produced around it as a concentric circles. It has been found that magnetic effect of current increases if instead of using a straight wire, the wire is converted into circular loop. A circular loop is fixed to a thin cardboard sheet tip. So the circular coil is fixed to a thin cardboard sheet tip. This is a cardboard. T is a cardboard sheet. Now, when a current is passing through the circular loop of a wire, magnetic field is produced around it. The pattern of magnetic field due to a current carrying circular loop is shown in the figure. Means the circular coil, in case of circular coil, the magnetic current is formed like this around the wire. In this way, the current is passed. In this way, the current means the magnetic field is formed. The magnetic field is formed. So in this way, the magnetic field is formed around. So similarly it forms. Yeah, means in this way the magnetic field is formed. Magnetic field lines. So these are represents the magnetic field lines. Magnetic field lines. So these are also magnetic fields. Now, so in which direction the magnetic field lines are formed? So when to understand, when the current is in the coil clockwise direction, the direction of magnetic field due to the coil points away from you. Away from you. The direction of the field due to coil are determined by using right hand rule. This states that we understand the direction of magnetic field due to circular coil, circular loop by using right hand rule. Right hand rule. This right hand rule stated that when you curl your right hand fingers in the direction of current, thumb gives the direction of magnetic field. So whenever we place our right hand like this, the curled fingers explain the direction of current, then the thumb denotes direction of magnetic field, right? Direction of magnetic. When you curl your right hand, when you curl your right hand in the direction of current, in the direction of current, the thumb denotes or determines magnetic field. So when we place our right hand like this, the fingers are denotes, means the fingers are denote direction of current, then the thumb denotes direction of magnetic field, like this. So the curl, when we curl your right hand in the direction of current, you see the direction of current, then the thumb denotes magnetic field, gives the direction of magnetic field, right? So in case of circular coil or in case of circular loop, so this is the direction within the center, this is I means direction of current and B means direction of magnetic field, right? So this is the direction of current. So when we place like this, the direction of current, then the thumb denotes magnetic field. So by applying right hand thumb rule, it can be seen that segment of circular loop carrying current produces magnetic field lines in the same direction with the loop. At the center of the circular loop, all the magnetic field lines are same direction and aid each other, due to which strength of magnetic field line increases. In case, so here magnetic field increases, here magnetic field increases, So this is the direction of current. So magnetic field line. Circular loop of wire carrying current, circular current, magnetic field lines. Magnetic field lines. So direction line. This is the direction line. So simply with our right hand. The magnitude of magnetic field produced by current carrying circular coil is at center is directly proportional to the center passing through the circular loop or wire and inversely proportional to the radius of circular loop. So, depending the magnetic field is formed by the circular loop is inversely proportional to the radius of circular loop and directly proportional to the current passing to the circular loop. Current passing to the circular loop. Amount of current is passing to circular loop. So, magnetic field proportional to current and magnetic field inversely proportional to radius. Inversely proportional to radius. So as usual, more current positive, more magnetic field is formed. Then the radius of the circular loop is more, magnetic field strength is less. If it is less radius, magnetic field strength is more. So the magnetic field is created or produced by a current carrying circular loop or the coil. Depends on amount of current passing the circular loop and radius inversely proportional to the radius of circular loop. In this discussion, we consider the magnetic field produced by circular loop, which consists of only one turn of the wire. And depending upon the number of turns. So here, if you take only one turn. If you take only one turn, then magnetic field is formed. Magnetic field is formed like this. So similarly, magnetic field line is formed line. So in case of a single, this has only single turn. This is the direction. This is the direction of the magnetic field. So magnetic, this is current direction, this is magnetic field direction. Magnetic field direction. Right? So when we place the magnetic needle, so we can observe that the orientation of magnetic needle. So we can say that direction of magnetic field due to coil points towards when the current in the coil is in anti-clockwise direction. When the current in the coil is clockwise direction of magnetic field due to the coil points away from you. So during the direction of electrical current, the direction of magnetic field also formed. Here given us so in case of current is anti-clockwise direction, then the magnetic field is towards you, whereas the current is anti-clockwise direction. current is anti-clockwise direction, anti-clockwise direction, the magnetic field is towards you. If the current direction is clockwise direction, it is away from you. So this is the direction of magnetic field. Direction of magnetic field. Like north and south pole are right then. So this is about magnetic field due to circular loop. So if the circular coil have N turns, the magnetic field produced by this current carrying circular wire coil will be N times large as the produced by a circular coil of single turn. This is because the current in each circular turn coil flows in the same direction, and magnetic field produced by each turn of circular coil then just adds up. So the field depends on the number of turns. If more number of turns, more current is passed in the same direction, more magnetic field. Then regarding to this, there is another law given, clock phase rule. 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 What is this clock phase rule? A current carrying circular wire like a thin disc magnet. We have different types of magnets: bar magnet, disc magnet, horseshoe magnet, right? Disc magnet whose one face is north pole and the other face is in south pole. The polarity of the two faces of the current carrying circular coil can be determined by using clock phase rule given below. According to the clock phase rule, look at one end of the circular wire coil through which a current is passing, circular coil. If the current around the face of circular wire flows in the clockwise direction, that face of the circular wire will be south pole. Clock phase. So here current clockwise, current anti-clockwise. So when the direction of current is clockwise, in a circular coil denotes the south pole of magnet. When the current is anti-clockwise, then it is the north pole. Pole of a disc magnet. The direction of current in the face of circular wire is clockwise. So this face of circular wire is current will be acts as south magnetic pole. So current is circular, means current is clockwise direction. So clockwise direction, this face which is appearing is a south pole of magnet. If the current is in the anti-clockwise direction, so this is the clockwise. This is the anti-clockwise, right? So clockwise. So if the current is in a clockwise direction, then this is represent the south. If the current is anti-clockwise direction, this is the north pole of a magnet. So this rule is called as a clock face rule. This rule is called as clock face rule. If the current around the face circular wire flows in a clockwise direction, that face of the circular wire will be south. If the current is anti-clockwise, then the face of the circular coil is north pole. So, if the direction of current in the front of the face of circular wire is clockwise, then the direction of current in the back face of the circular wire will be anti-clockwise. So, imagine that front side clockwise, back side anti-clockwise. Front side is clockwise, then back side anti-clockwise direction current can flow. This means that the current carrying circular wire will be a south pole, but its face will be north pole. Similarly, if the current carrying circular wire will be a north pole, but the face will be south, opposite to north. So, the clock face rule is also used to determine the polarities of the two faces of current carrying wire, current carrying solenoid as well as an electromagnet. So, finally, magnetic field due to circular loop or circular coil. We'll explain with right hand rule. The curl is the curl fingers. These fingers denotes the direction of current. The thumb denotes the magnetic field. So single circular coil, regular form, the double means the strength of this magnetic field depends on number of turns in the circular coil and the radius of circular coil depending upon the strength of magnetic field is dependent. So strong magnetic field or weak magnetic field. So this is about magnetic field due to circular coil or the loop. Circular coil